Okay, now let's talk about perspective through comparisons. Comparisons are particularly useful in dealing with units that are relatively unfamiliar, such as energy units. So that's what we're going to be dealing with right now. It's a little bit of energy units, okay? So we're going to talk about joules. So use the data in the table below to determine how many average candy bars an adult would have to eat to supply energy needed for 7 hours of running. So we know we're going to be running for 7 hours. Not me, but maybe you. Okay, so we look here and we see that 1 times 10 to the 6th is the energy released by metabolism of one average candy bar. So candy bar, 1 candy bar. Energy needed for 1 hour of running for an adult is 4.4 times 10 to the 6th, okay? So let's figure this out. We know we have 7 hours that we're going to be running, so 7 hours. I'm going to multiply that by 4.4 times 10 to the 6th. 10 to the 6th. And that's joules per hour because it says for 1 hour. So here we can cancel our hours. 7 times 4.4 times 10 raised to the 6th, and that was joules, right? So we could do that math. Excuse me, 7 times 4.4 is going to give us 30.8 times 10 to the 6th joules. And we also want to incorporate this information, and we know that it's 1 times 10 to the 6th joules per candy bar. So 1 times 10 to the 6th joules, all of that is per bar, candy bar. If I'm going to put bar because that's less, right? Lazy. Okay, so we could cancel both of these. And that's going to leave us with, well, 30.8. And then all we're going to have left there is bars, right? So it's 30.8 per bar. That was over this, then we bring the bar up to the top. That was, all that was over a bar. So it's 30.8 bars. But if we round, that's going to be approximately 31 bars. Bars is how many candy bars we're going to need. So an adult would need to, the adult would have to eat approximately 31 candy bars. So we're going to use the table to answer the following questions. Same color I just used. Let's pick a new color. Compare the energy released by fission of 1 kilogram of element B to that released by burning 1 kilogram of element A. Fission of 1 kilogram of element B releases blank times as much energy as burning 1 kilogram of element B. So to find this, we're going to use our information up here. We're going to have 1.8 times 10 to the 13th power. We also have, that is for the fission of hydrogen in 1 kilogram of element B. Then we have 5.8 times 10 to the 10th, and this is the energy released by burning 1 kilogram of element A. So we're going to use 1.8 times 10 to the 13th over our 5.8 times 10 to the 10th, okay? So when we divide 1.8 by 5.8, we're going to get 0.31. And then remember, we always subtract the bottom one from the top, so that would give us times 10 to the 3rd power, right? Or 10 cubed. But we have to write this as a number between 1 and 10, so let's do that. So we're going to move our decimal point over 1 place, so that would give us 3.10. When we move it 1 place, we take 1 power away, so that's going to be times 10 squared. 10 squared is 100, so we could say 3.10 times 100. If you do that math in your calculator, that's going to give you 310. So 310 times. Okay? All right, now let's talk about perspective through scaling. So verbally, we say 1 centimeter equals 1 kilometer. Graphically, I'm just going to wipe this out because I can't type ratio, obviously. Bad. Once again, that's why I'm not an assistant of any type, I guess. So as a ratio, it's 1 centimeter equals 1 kilometer, which means that the scale ratio, ooh, I typed it right there, of 1 to 100,000, okay? So we're going to find the scale ratio for the map described below. We have 1 millimeter on the map represents 100 meters on the ground. Okay, so the easiest way for me to show you how to do this is the way I do it anyway. So we're dealing with meters, so I'm going to use this little scale, or this little table from the other day's notes. So we know we're dealing with meters, and we want to go from, we want millimeters. So I always look at this, and I think meter. So we're going to deal with millimeter, which is here. So we're going to go millimeter, decameter, centimeter, millimeter, okay? And every time you're going up by 10. So I always draw me like a little chart like this. So we have millimeter. So I do decameter, centimeter, millimeter. Opposite way. This is decimeter, centimeter, millimeter. Sorry, I said it wrong. This is decameter, which is D-A-M is how you, that's the, and then here's hecameter, so kilometer. Okay. So every time you move over 1, you're multiplying by 10. So we're going to start here. We're going to go 10, 100, 1,000. Okay? So we have 100 meters is where we're going to start. So we're going to start here, and like I said, every time we go over by 10. So 10, 100, 1,000. Okay? So that's how I think about it in my head. So I have 100 meters. And if I want to do 1 meter, it's going to be 1,000 millimeters to 1 meter. So then now we can cancel the meters, and then we just multiply these, which then that's going to give us 100,000 millimeters. So that's 1 to 100,000. That's easy. That's how I do it. I think that's the easiest way to do it. Obviously, that's the way I do it. But that's the way I'm going to show you guys how to do it, because like I said, I think that's the easiest way. You just draw your little thing based off of 10, 100,000. Okay? All right. Now we're going to find the scale ratio for the following map. We have 1 inch on the map represents 12 miles. So we need to write down some things that we know, that we've already established. We know that 1 mile, 5,280 feet, right? We've used that at least once, maybe more than once. And we know that 1 foot is 12 inches. I know we've used that multiple times. So we're going to, inches on the map represents 12 miles. So let's use 12 miles miles to cancel, so where would the miles go? On the bottom, 5,280 feet. Now we're going to want the feet because we want it in inches, right? So let's put the feet on the bottom and 12 inches on top. Start our canceling. It's 12. It's 5,280 times 12 inches. So when you do that math, you're going to get 760,000. It's a comma, 320 inches. So that would be your ratio. So there are approximately 2.6 million deaths per year in country A. Express this quantity as deaths per minute. Okay, so we want deaths per minute. We got deaths per year. So we're going to have to do a little figuring of our facts, and then we'll be able to do that. So we know that 1 year is 365 days, right? Because we're going to have to go from year to minutes. So we're going to have to break it down from year to there. So we know that 1 day equals 24 hours. Then 1 hour, 60 minutes. Okay. And we know that million equals what? 10 to the 6th. If you said that, you're correct. So we have 2.6. I'm going to scoot down here so I'm not writing into my little box. So we have 2.6 times 10 to the 6th. And this is our deaths per year. Right? So that's what it says. 2.6 million, which is this, deaths per year. I should write deaths. Be correct, sorry. Okay, let's multiply that. Now we're wanting to get rid of year, and we're wanting to turn it into minutes. So where would I put my year? Top. 365 days. So now we're going to want to cancel days, so we're going to put day on top, 24 hours on bottom. So we do this one and this one. Now we're going to want to cancel hours because we want it to be minutes. So we're going to put hour on top and 60 minutes on bottom. Okay? So now let's start with our cancellation. So year cancels, days cancel, hours cancel. We're going to have 2.6 times 10 to the 6 deaths. All right, that's the only thing on the top that we have, only thing in our numerator. Now let's see what we have on the bottom. We have 365 here, and then times 60 minutes. Oh, and I have 24. Shoot. Yep. I just skipped right over 24, my bad. Huh. No, that's right. Okay. So let's put it in the calculator. So 2.6 times, you probably need to see how I do this. Maybe not. 10, and then we hit the little caret button to the 6th. I'm going to hit enter. That gives me, usually do it as two different things. Just makes it easier. I have to skip that over so I can write it. There we go. 1, 2, 3, 4. All over. 365 times 24 times 60. It's all going to be over 525,600. Now, how I usually do this is I arrow up, and once you're on that, you can hit enter, and it brings it down and makes it active again. And then you can hit divide, and then go up here and hit enter, and it brings it down and makes it active, and you can hit enter again, and then it gives you your answer. So it's 4.946727549 is the exact answer, but it says type as an integer or decimal rounded to 1 decimal. So it's going to want it here. So we look at this 4, and since it's less than 5, we don't touch it. We just leave it alone. So our approximation is going to be 4.9, right? 1 decimal. So there's 4.9 deaths per minute. That was our unit. Oh, I should have wrote deaths. Sorry, deaths per minute. There we go. Got carried away, forgot this. That is the end, okay? Y'all have a great day.